Hello, Algebra 2. How's it going? How's it going with you? It is week 5. It is the second assignment. It is 5.2. We're going to talk about some asymptotes today. Again, asymptote, a line that continually approaches a given curve but does not meet it at any finite distance, all right? So, again, maybe you have this asymptote here, and you've got, let's say you've got an exponential decay, and it starts getting really close, and it's just going to kind of settle out and just keep going forever and ever. It's never going to cross that asymptote, but it's just going to keep getting closer and closer, all right? Again, we've talked about this a while, but I just want to make sure we know what that fancy word is, asymptotes. All right. You can have horizontal asymptotes. Again, those are, if we had to sketch them real quick, I'm going to provide sketches with all these. Let's see, we've got, oh no, isn't life just great? Okay, there you go. Here's my little coordinate plane. Horizontal asymptote, we've got something like this, all right? And maybe your function, just like what we talked about, maybe your function looks like that, right? Horizontal, they always have an equation of y equals something, because along this line here, your y value is always going to be equal to, maybe this is at 3, right? Your y value is always equal to 3 along here. Or if your horizontal asymptote was at -5, right? Y equals -5. Everywhere along this horizontal line, your y value is always -5, all right? So you could have horizontal asymptotes. You could have vertical asymptotes. We'll get to slant asymptotes in just a second. Vertical asymptotes, let's see if I can try this again. Hey, there you go. Vertical asymptotes, all right? Right there, vertically, all right? And again, these have x values, right? They have an equation with an x equals something. Maybe this is at -6, right? So this would be the line x equals -6. It's a vertical line up and down. Again, all along this line, all of these points have x values of -6. They may have different y values, but they have x equals -6, all right? So we've just seen these basic rational equations, and we're kind of going fast through this chapter. We've just seen horizontal asymptotes and vertical asymptotes, but now we may have slant asymptotes, all right? Slant asymptotes are exactly what you would think of them to be, as they are a line, but it may not no longer be a vertical or a horizontal line. It may be at a slant, all right? So maybe you've got a line, you've got an asymptote that looks like this. Maybe it's the line, I mean, that's a linear line. Let's say it's x plus 2, right? It's got a y-intercept at 2. It's got a slope of 1. You've got this line, and you may have a rational equation that has, it may have a vertical asymptote that looks like this, but since we have that slant asymptote, it no longer goes horizontal like this, right? Maybe it goes like this and then starts following that slant asymptote, right? Again, on the other side, maybe it's got this vertical asymptote, and then it starts following that slant here, all right? So these are slant asymptotes. I'm planning next week we'll actually do some long division to find how to actually find these slant asymptotes. But for right now, I want you to identify when a function would have a slant asymptote. And there are a couple of rules. So the rules for determining if a function has a slant asymptote or not is that you look to the degree of the numerator and the denominator. So we could say that you have a rational function f of x equals, and if I believe I said this before, rational functions, it's really just a function being divided by another function. So you could have a polynomial or a function p of x being divided by q of x, and that is what makes it a rational function, right? Rational numbers, you're thinking about fractions. You've got a function divided by a function. It's written as a fraction here. So you would look at the degree of p of x, and you would look at the degree of q of x. And if you remember, degree is the highest, the biggest exponent that you have in your polynomial. So let's say that you have a function f of x equals, I'm just going to make one up real quick, let me make a different one up. X to the fourth plus 3x cubed minus x. All right, that would be like maybe your p of x function. It's the numerator divided by x cubed minus 2x squared plus 3. All right, that would be the denominator, our bottom function, like q of x, right? So this is a rational function. And when I say degree, we're looking at the highest exponent. So in both of these, my highest exponent on the numerator is 4, all right? And the degree of the denominator, the highest exponent there, is 3. So the rule is that you will have a slant asymptote if the degree of the numerator is greater than the degree of the polynomial in the denominator, all right? So here, since I have a degree of 4 on top and I have a degree of 3 on the bottom, well, yes, indeed, 4 is greater than 3. This function would have a slant asymptote. Alrighty. So that's kind of the rule. If the degree in the numerator is higher than the degree in the denominator, then your function will have a slant asymptote. Let's look, I'm just got 3 more examples that all are slant asymptotes so we can see this, all right? So I'm just going to break this down here. I'm going to use the green. X squared minus x plus 4, that's like the function on the top in the denominator, or in the numerator. It has a degree of 2. The little polynomial in the denominator, let me stutter over my words again, 2x plus 2, it has a degree of just 1, all right? So I'm going to pull that 2x plus 2 here. Technically, again, it has like an invisible, this x is being raised to an invisible like 1 there. So we can just say that it is a first degree polynomial, all right? So this bottom would have a degree of 1, and since the degree of the numerator is greater than the degree in the denominator, this would have a slant asymptote, and we do see this slant asymptote right here. Again, a line that our function approaches but never crosses. Later we'll find out how to find, I'll show you how to actually, find the equation of that slant asymptote, but right now I just want to identify that it has one or not. And it would still have a horizontal, or excuse me, a vertical asymptote. Again, if we look at this denominator, it has a denominator of 2x plus 2. I got to make sure that that is not equal to 0. So to check for a vertical asymptote, I still can set that equal to 0 and solve. I'm going to minus 2 from both sides, and I got 2x equals negative 2. Divide by 2, and I got x equals negative 1. And that kind of checks out, right? I would have a vertical asymptote at x equals negative 1. And that's probably about right here. Here's my vertical asymptote, all right? So this thing has a slant asymptote because I've checked those degrees, and it also has a vertical asymptote because, again, we still can't be dividing by 0. We have to make sure that that denominator is not equal to 0. So we would look at where our asymptote would be. And if we wanted to write the domain, just for some good practice so we see this, the domain of this function would be, okay, it exists, the function exists so far, it exists so far, I hit that vertical asymptote of negative 1, and all of a sudden, again, we can't have an x of negative 1 because it would mean that we would be dividing by 0 in the denominator. And then again, after that negative 1, we're good, the function is defined. So our domain, we could say, would be all x values such that x is not equal to negative 1. All right, that would be good practice. Okay, let's go with the next one here. All right, here again, let's just check and see. We can see the graph, and we see it definitely is going to have some sort of slant asymptote. Again, we'll find out how to do these later, but again, if I check, I have a degree of 2 in the numerator. In the denominator, it's a first degree polynomial, right? Just x to the first power minus 2. So since my degree of my numerator is greater than the degree of my denominator, then this does have a slant asymptote. Let's draw those asymptotes real quick again. I've got that slant asymptote about right in here somewhere. It's a linear line. And I'm also going to have a vertical asymptote. Again, this thing cannot be equal to 0 in the denominator. Otherwise, we would be dividing by 0, right? So if I set x minus 2 equal to 0 and solve, I would have x equals 2. So I should have, if this is in our graph, 2.5, so maybe 2 is about right here. And yeah, that checks out with our graph, having a vertical asymptote at x equals positive 2. All right. Ugh. Ignore that for now. Hang on. Okay, this is another one here. Again, we'll see how to find that slant asymptote a little bit. It's going to involve some division. Anyway, over here I have a degree of 2. I've got a degree of 1. It's a first degree polynomial again. Yes, the degree of our denominator is bigger, so this has to have our slant asymptote. And we see our slant asymptote right here. And then our vertical asymptote, again, what makes that denominator 0? Let's check by setting it equal to 0 and solving for x. X equals 3 would be our vertical asymptote. And right here about at 3, we have that vertical asymptote, so that checks out. Okay. Wonderful, wonderful. Let me know if you have any questions. I am going to link a video also with this one where a guy talks more about this if you want to see that. We're going to get some practice with it. All right, don't worry. Hang in there. You're doing great. In your homework, I am going to ask you, what do you think the graph of 1 over x squared would look like? All right, so I'm going to have you think about that question. You may want to use the fact that the graph of 1 over x, looks like this. All right, looks like this. So what would happen if we squared the bottom? All right, think about it. Think about it. Don't cheat. Please don't graph this on Desmos. Give an honest thought. Think about it, and then you can graph it and check yourself. All right. So what would happen? What do you think the graph of 1 over x squared would look like? Have a great day. Enjoy this little video of my aunt's cat. I have another aunt. This is the cat named Storm. I do not like him very much, but he is quite cute, and he likes to jump and sleep. Have a great day. Go team!